Okay, we're going to look at even and odd functions and how it applies to trig functions. Okay, first of all, we need to define what an even function is and what an odd function is. So, definition is here for an even function. Okay, so an even function is even if when reflected in the y-axis, it looks the same. So if you take the function and you flip it in the y-axis, flip it over, so it's a horizontal transformation, it looks the same, then it's even. Okay, so f of negative x equals f of x is the algebraic way of looking at it, where f of negative x is just a reflection in the y-axis. Okay, so if you reflect in the y-axis and it looks the same, it looks like f of x, then it's an even function. Odd function, there's an extra step. So an odd function it's an odd if when reflected in the y-axis and then reflected in the x-axis, it looks the same. So it has to go through a double reflection here. So if it's reflected in the y and the x, or the x and then the y, doesn't matter which order, and it looks the same, then you have an odd function. So here, if you look at this inside negative means a reflection in the y-axis. The outside negative means a reflection in the x-axis, so it's doing both. So this is what's happening. Or you can write it like this. This is the more useful way of writing it. This way, in both cases, I can check to see what f of negative x equals. And then if it equals f of x, I have even. If it equals negative f of x, then I have odd. Okay. For odd, it's the same effect. So if you reflect in one axis and then the other, it's the same as rotating it 180 degrees. So if you rotate something 180 degrees, it's like reflecting it at one axis and then the other. And we'll see that. Okay, so here's a couple of examples. First example, f of x equals x squared. All right, so for f of x equal to x squared, well, we know what this looks like. It looks like this parabola here. Okay, so you can see that if it's reflected in the y-axis, it looks the same. So it should be even. And here's what we're going to test. So we're going to test f of negative x. When you put negative x in for x, and f of x equals x squared, you're going to look at this. And when you square a negative, you get a positive. So it looks like x squared. So f of negative x is the same as f of x. And you think of it here, f of 2 is this going to be the same as f of negative 2. Okay? So it equals f of x, and that implies that we have an even function. Okay? Now the next one we're going to look at is x cubed. Well, we know what x cubed looks like. Okay? It looks kind of like the x squared, but with this, the bottom or the left side of the parabola, instead of opening up, it opens down, because when you cube a negative, you get a negative. Okay, and we're going to do the test thing again. So we test f of negative x. We put negative in for x cubed. You cube that, and whenever you cube a negative, you get a negative. So that gives us negative f of x, and that implies we have an odd function based on our definition of odd. F of negative x equals negative f of x. Okay. So that's some basics for even and odd. We'll do a couple more here. Okay. For this one, okay, so for f of x equals x squared plus 2x, if you wanted to figure out whether this is even or odd, you need to sub in negative x wherever there's an x. Okay, and see what you get. Well, when you sub in negative x, so negative x for the x squared and negative x here, well, when you square that negative x, it becomes positive. This one stays the same. Okay, so f of negative x equals x squared minus 2x, not plus 2x. So it doesn't become the same function. It doesn't equal f of x, nor does it equal negative f of x. So it's neither even nor odd. And if you look at the graph of this, you can factor out x. So you factor x out of this, you get x times x plus 2. And we know what that graph looks like. It's a quadratic with 2x intercepts here. And if you reflect it in the y-axis, it's not going to look the same. It's going to look over here. And if you reflect it in the y-axis and then the x-axis, it's not going to look the same because it would be upside down there. Okay, so that one's neither. And if you had something like this one here, so negative 3x to the fourth plus 7 over 2 minus x squared. If I replace all the x's with negative x, this is what I get. Okay, so you can pause and check this out to see what you get. All right, so when you work that out, you should have this. And that looks exactly like what we started with. Without the graph, we don't need the graph for this to check it. We can just do it algebraically. And that implies we have an even function. Okay? What if we had something like this? So if we notice this one above here, we had only even powers in it. And it worked out to be an even function. Well, what if we have only odd powers? Okay, so you might want to pause and try this and see what you get. So for this one, when you put negative x in, again, when you cube negatives, you get negatives. So you get this and this, which is neither f of x nor negative f of x, so we have neither. So just because all the exponents are odd does not mean you're going to get an odd function. Okay? Now, let's see how this applies to trig. Okay? So, sine of x. F of x equals sine of x. Well, when we graph that function, we've basically got this. Okay, so I went from negative 2 pi to 2 pi. Now, if we reflect that, okay, so we do this reflection in the y-axis, we get this graph. So you take this side, reflect it over here, this side reflected over here, we end up with this graph. Okay, and that looks like the negative sine of x. So we could stop here and say that that's negative sine of x. Or we could do another reflection. Okay, so we do the reflection in the x-axis, so we'll reflect it this way, or this way, and we end up back with what we started with. So we can say that negative sine of negative x equals sine of x, or we can say sine of negative x, which is what we had here, equals the negative of sine of x, and that implies that we have an odd function. So sine of x is, in fact, an odd function. Okay, and cos of x, well, this one's simpler. Works out nicer. So cos of x is this graph. So we've got that graph. And cos of negative x, well, if you look at it here, if you reflect it in the y-axis, it looks exactly the same. So it's the same. So cos of x is an odd function. So cos of negative x equals cos of x. So cos of negative 2 is going to equal cos of 2. Okay, the y values. So cos of x is an even function. Okay, some examples of this would be if we just did sine. Sine of negative 30 degrees is the negative of sine of 30. Okay, so we go back to the sine graph way up here. So sine of 30 degrees and sine of negative 30 degrees. They're the negatives of each other. Okay? And so sine of negative pi over 7 is the negative. Sine of negative pi over 7 is the negative of sine of pi over 7. And then cos of negative 30 equals cos of 30. Just by looking at the graph, we just looked at that. And cos of negative pi over 7 equals cos of pi over 7. Okay, so let's look at some more examples of this type of stuff. So other equivalent trig expressions. All right, so let's see if sine of pi minus theta equals sine of theta. Okay, see if they are equivalent, no matter what theta is. Okay, so let's take a look at this proof that I have over here. Okay, so I've drawn a circle, could be a unit circle, but I just said that the radius was r. And I have an angle in here, theta. Okay, so that's our theta. We're just making it an acute angle for now. If that's theta, then there's pi over 2. There's 0, pi over 2. There's pi. This would be 3 pi over 2. Then pi minus theta is going to be pi minus theta, which is this angle in here. So that's pi minus theta. Now, if I want to find the value of the left side, well, I'm going to make coordinates for these points here on this circle. So if that is A comma B, then this triangle over here is similar to this triangle. It's actually congruent to this triangle. So that A becomes a negative A, but the y stays the same, so that stays B. Okay, I'm just putting that point over here. That's a negative x value compared to that positive x value. Okay, so the left side, sine of pi minus theta, is going to be b over r. Sine, remember, is y over r. The y here is b, so b over r. The right side, sine theta, is just b over r, y over r, right? And that equals the left side, so they're both the same. Therefore, sine of pi minus theta equals sine of theta, and they're an equivalent expression. Okay, let's try another one. Cos of pi plus theta, does that equal negative cos theta? So you might want to pause and try this. Okay. Now, here's proof. So there's theta again. This time instead of pi minus theta, it's pi plus theta. So the angle pi plus theta goes all the way around here. Okay. And if this is AB, those are the x and y coordinates. Over here, they're going to be the negatives of those. Okay, because this triangle here is congruent to this triangle right here because of that angle, and they're right triangles. Now, finding the cos of theta. So the right side of this part here, the left side, is cos pi plus theta. So pi plus theta. So cos is x over r. X is the negative a here. So negative a over r. And the right side, the negative of cos theta, well, cos theta is just a over r. So the negative of that is going to be negative a over r. And they're the same. So the left side equals the right side. And we've got this proved. Okay. Another way of looking at that same one and others is looking at the graphs. So cos of pi plus theta, you can write it like this, theta plus pi. That's a translation of pi to the left. Okay, so if I took cos theta, which was here, and I move it pi units to the left, I get this function, which is just negative cos theta. Okay, so that's it for now for equivalent trig expressions.